Awesome. You have great ideas, Marissa. We're going to write them down so we don't forget. All right. So today you begin the net change theorem. Today is a day where you begin kind of entering into that phase where it's not about memorization, it's about understanding. So I understand that for you guys, you need to memorize that the derivative of sine is cosine. The derivative of natural log of x is 1 over x. And the derivative of secant of x is secant of x times tangent of x. And the derivative of e to the x is? So I get that there are those memorization pieces. This is an understanding piece. So this is where you kind of want to focus all in. This is where we start kind of one of the most commonly asked free response questions from the AP exam. This is going to give you a nice idea. So this is a really big deal. This will basically take us about the rest of the week, okay? So when you see some of the problems, you're going to say, well, they look complicated. They are. But what I found is actually people work through this challenge pretty well by the time we get to the test. It's some of your antiderivatives that give you some trouble. So let's start understanding what the heck it is that we are doing. We're going to use the integral for its great application, which is displacement and distance. What do you estimate the distance from me to Maddie to be? Somebody? 15 feet. We're going to go with Tim. So we are going to walk. You guys tell me, what is my total distance that I've traveled?
Well,
30 feet. Thank you, Maddie. I traveled 15 feet there and 15 feet back. Don't know why you're counting my steps. Okay. All right. Now I want you to tell me what my displacement is, meaning how far am I located from where I started?
Oh, we learned 15. 0.
0. Notice how I can walk there and back again. Great book, anybody? I can walk there and back again, and my displacement is 0, which is definitely different than the distance that I've traveled, is it not? So displacement is this. The integral it's the integral of the velocity function. The integral of the velocity function will provide you your displacement from A to B. If you want to know the total distance traveled, well, consider that if I'm traveling in the direction to the right, that is positive. If I'm traveling to the left, that is negative. So if I travel 15 units to the right, and I travel 15 units to the left, you can see that 15 plus negative 15 is 0, right? So that's the displacement, but the distance is a total of 30. We simply take the absolute value of each, right? Or the absolute value of the integral. Instead of writing it like that, you can also write the integral from A to B of the absolute value of the velocity function. That would probably be the better way to write it. Just put absolute value signs around the velocity function. Okay. So we're going to show you how to do this in multiple ways. And today we're going to do it without the use of your calculator. We're going to teach you how to use it with your calculator later on. I just wasn't able to fully erase it. So we're just going to get rid of that little spot right there. There. Is that better? Everybody okay? All right. So again, this is a big idea process. We're going to try to test on Valentine's Day, I think. The day that Whitney, before she gets her wisdom teeth out, right? Okay, that's the goal. Particle moves Particle moves at this velocity right here. Okay, particle moves at that velocity right there. And it's measured in seconds. V is measured in meters per second. Notice we're not given the position function, we're given the velocity function. It says find the net change or the displacement of the particle and also find the total distance traveled. So I'm going to find A, which is simply going to be the integral of the velocity function, dt, over the time 1 to 4. Now, I'd like you to kind of understand ahead of time. This is easy. Like, we just take an antiderivative, we plug stuff in. But this is where you need to start to understand what the heck it is we're doing and why. Let's look at the velocity function. What shape does that make? Makes a parabola. In fact, I could find the x-intercepts, could I not? This factors to what? Yep, t minus 3 and t plus 2. So that means we have a velocity function that crosses at -2 and at positive 3. As I graph the function, well, did not do a very good job there. Try again. Okay. All right, let's see if we can recall anything that we've done before. Looking at the graph, try to tell me when is the particle traveling to the left, and when is it traveling to the right, and when does it change direction? Talk to your peers. Go. Five, four, three, two, one. Anybody tell me when this particle is traveling to the right? Tim. Infinity to infinity? Why do you say that? You can see that the velocity is positive here and here, which means it's traveling to the right. I'll forget about the negative time, but it's traveling to the right from 3 to infinity. And if we say that time starts with 0, we'll say it's traveling to the left from 0 to 3. So therefore, it changes direction at what time? Changes direction at 3. That's where the velocity changes from negative to positive. Kind of remember that? If we look at the integral represents the area, doesn't it? Or in this situation, which is kind of cool, you're looking for application of the integral. The integral represents the distance traveled in the negative direction, and then the distance traveled in the positive direction, so all the way up to 4. Do you think it's traveled more in the negative direction or positive direction? Negative direction. So the overall displacement should be further to the left. Does that make sense? You can see that the area above the curve here, where it's traveling positive, is smaller than the area the other direction. So let's use that to be able to find this total displacement. So I'm trying to give you the conceptual piece so you understand what's going on, because this is going to be asked in many different ways and forms when you get to the AP exam. And as I look, I would say that when we get to these problems on the AP exam, people are scoring like 5 out of 9, which is a good score. You know, average for most people across the country is, say, 3 out of 9. But people do well with this. We do a good job preparing people for this. It's when we get to some other things it's more challenging. So let's try to get that 5 out of 9. By the way, some of you guys, when you get this part in the AP exam, you'll be getting a 9 out of 9. Like you have no problem with it, which will be great to see. So let's give it a shot. We have the integral from 1 to 4 of my velocity function, which is t squared minus t minus 6 dt. So this is a definite integral, meaning we will produce an answer. The answer is the displacement of the object, which you've already determined will be negative. So how do I do this? Good, antiderivative, which is? T cubed over 3 minus? Good. Good, and we're going to evaluate at 4 and at 1. So I'm setting up the antiderivative. These problems will be asked both to do by hand as well as by calculator on your exam. I'll tell you what to expect on your test. I plug in 4 and I get 64 over 3 minus 16 over 2, which is 8, minus 24. Everybody okay with that? All right, and then I will subtract, and what do I plug in now? 1. And I get 1/3 minus 1/2 minus 6. Now, as I do my work, if I'm asked to do it by hand, I showed you kind of my trick. I like to look at, the common denominator. So 64/3 minus 1/3 is 63/3. And 63/3 is the same as 21. So those cross off, give me 21. And notice how I have this nice array left here. So I've got 21 minus 8 minus 24. It's going to be plus 1/2 and plus 6. So as we evaluate this, 21 minus 8 is 13. 13 minus 24, negative 11. Negative 11 plus 6. Negative 5 plus 1/2. Negative 4.5. Now, it's located negative 4.5 units from where it started. So we said it should be further to the left, which is exactly what we thought. Everybody agreed? Okay. So what we're going to do here is put our label negative 4.5 meters from where it started. And that is the kind of the basis for which we begin. So everybody okay with that? All right. So let's do part B. How is part B different? Yeah, the absolute value, which is kind of a challenging idea. We're looking for the integral from 1 to 4 of the absolute value of t squared minus t minus 6. And so if we state the obvious is that taking an absolute value of a function is not something we've really thought about before, is it? It really isn't. And so how do we calculate something like that? Okay, it's not that bad. All we have to do is look at our original graph right here, and I'm going to draw the absolute value of that function. Are you ready? The absolute value of that function is going to look like this. I will draw it in black right over this. It will look like this. See that? It will just take whatever was negative and make it positive. And so all we need to do is find the negative area and make it positive and add it to the positive area. That's all we have to do. Take the negative area, make it positive, and add it to the positive area. Not quite. What we're going to do is we are going to divide this into two integrals. And the two integrals will be one for the negative area. So we'll take the absolute value of the negative area and we'll add it to the positive area. So what would the integral look like to represent the negative area? The integral from what to what? 1 to 3 of t squared minus t minus 6 dt. And we'll take the absolute value of that. And then we'll add that to the positive area. What integral would represent the positive area? Integral from 3 to 4 of t squared minus t minus 6 dt. Yep. Notice how our bounds are from 1 to 4, but it's at 3 that it changes from negative area to positive area. So I'm choosing to break it at 3.
Okay.
So I had to find where it switches from positive to negative.
So then you can start. Oh, okay.
So I'm going to do from this one spot where we begin to 3, because that's where it's the negative, and then from 3 to 4, that's where I have my positive.
Then, like, to find the shaded area, do you want us to pick that in our calculator?
Nope. We're going to do it by hand.
Yeah. So then, how would we?
We'll do it just like we did before. So we're just going to do the antiderivative. And so what I'm going to have you guys do is, well, let's do it together. We have t cubed over 3 minus t squared over 2 minus 6t, evaluated at 3 and at 1. And we're going to add that to t cubed. over 3 minus t squared over 2 minus 6t. And we're going to evaluate that at 4 and at 3. You sure can. I just left them off, just saying that we're gonna eventually take the absolute value of that. But yes, we will take the absolute value of this. Yep. Okay, we put. No, the first one. All right, plug in 3. What do you get? 9 minus, as you said, 9 halves minus 18, whatever 6 times 3 is, very good. Minus 1/3 minus 1/2 minus 6. So let's evaluate that first. Should that answer come up positive or negative? Should come up negative because we're finding the negative area. We will then make it positive. That's what you're referring to. Yep. So I've got 9 and negative 18. Negative 9 minus a negative 6.
Oh, no.
9 minus 18 is negative 9. Minus the negative 6 will be negative 3. So I'm going to cross off the 9, the 18, and the 6.
Oh.
Okay. Then I've got negative 9 halves minus a negative 1/2. Negative 8 halves, which is negative 4. So I've got those. And then I have minus a 1/3. Negative 7 minus 1/3. Negative 7 and 1/3, otherwise known as negative 22 over 3. So I did come out with a negative value, didn't I? So we'll end up making that positive, but first let's find this value over here, okay? So I plug in 4, and we've already done that. We get 64 over 3 minus 8 minus 24, and I'll subtract 9 minus 9 halves minus 18. Okay. We don't have anything nice to do with the third, do we? So we'll just put the 64 over 3 and deal with that in a second. Negative 8 minus 24. Negative 32 minus 9. Negative 41 plus 18. Negative 23. So that takes care of the 8, the 24, the 9, and the 18. And I have a plus 9 halves. Yep, common denominators. What's the common denominator? So multiply top and bottom by 2 here, and I get 128 over 6. Top and bottom by 6. What's 6 times 123? 132. Top and bottom by 6. I'm sorry, top and bottom by 3. Yep. Okay. Well, this isn't too bad. 128 minus 132. Negative 4, negative 4 plus 27. 23. So we have negative 22 over 3, and we have 23 over 6. So we're going to make this positive, right? And so I need to create common denominators. So 44 over 6 plus 23 over 6, which is 67 over 6. otherwise known as 11 and 1/6, right? Did I make a mistake somewhere there? Anybody catch a mistake somewhere?
Is this not right or what?
138.
Oh, 138. Very good. Yep. Sorry about that. What's that? Well, maybe we could go back after we're done.
Okay, so negative 10 plus 27.
So negative 10 plus 27 is 17. So it's not 67, it's 61 over 6, which is 10 and 1/6. Let me show you how to verify on your calculator, and you can start working. Take out your calculator.
So like when you were looking for that graph and like how you highlighted it, so how do we know like how do we know one? Because it starts there.
Yeah.
Okay.
Yep. Yep.
That's kind of what I was trying to ask you. Like I didn't know like
Okay.
you wanted no.
Everybody okay with that? That's our velocity function. Am I okay to go? Okay, I'm going to zoom standard. I see the parabola just like we graphed. It went through -2 and +3. Notice how we did this all by hand. That's what Isaac Newton and others would have done. They did not have graphing calculators. And I will calculate number 7. And we will go from 1 to 4. Should I come up with a positive or negative answer? Negative. We've already determined that, haven't we? In fact, we come up with a -4.5 exactly like we thought, right? So, you've already seen that. How do you do the absolute value piece? This is kind of fun. If you go back into y equals, and I'm going to insert an absolute value function. And I'll show you how to do it. You can either erase it, retype it, or you can do second insert. So above your delete is INS, which is insert. Yep. Notice how it's blinking because it wants to insert something. And I press second mode or second delete because it says INS. Okay. And then I'm going to go second catalog to get ABS. Now, some of you guys have math print where it brings up ABS. If you don't have that, then you're going to have to do something else, okay? So then you have to retype it inside the absolute value, okay? Yep, or if yours brings up the absolute value symbol, then just type in t squared minus t minus 6.
Yeah.
Yep, so then just put that in there. So put x squared minus x minus 6 inside there, okay? So I've got that. If I look at the graph, it will do exactly what we said, where see how it bounces off like that? Yeah. And then we're going to calculate the integral number 7, and we're going to go from 1 to 4. And there it is. What's interesting is look at your calculator. Is that the actual value? That's an estimation, isn't it? We know it's 10 and 1/6. Your calculator can't do it quite as well as we can, which is interesting. You are smart at calculator. 0.16 repeating. So you guys are able to start your assignment. Go ahead, Easton, right up here.
Self-control, Maddie. It's doing the stuff. So that way you don't. It's just the issue again.
everybody's waving to me. I figure I wave back. I'm feeling friendly. So see how the integral's from 1 to 4? So this parabola crosses the x-axis at -2 and at +3. It looks like this. Okay? So we're going from 1 to 4. 1 to 3 represents the negative area. 3 to 4 represents the positive area. Yes.